So when it comes to text mining, we are certain that it's unstructured data. And we also understand that we need to make the data structured to be able to proceed further. May I ask you on what are the various techniques that you apply and what is the flow pipeline to convert the data, which is unstructured, into a structured format? And if you may share your screen with probably the GIF image and then explain, that might help our students understand better. Thank you, Sharat. Over to you.
Yeah, thank you, Bharani. Glad you could connect. Yesterday, I was lone wolf, taking the hat of, donning the hat of both interviewers and interviewee. Now the conversation becomes more interesting, and I'm pretty sure our audiences will enjoy the conversations. So let me share my screen. Friends, as yesterday we were trying to understand a few of the concepts of the text mining, the high level flow I was trying to show, give you some insights on how the data looks like, what is the data basically treated, how it is treated and all that. So taking the entire discussion in a phase wise today, as Bernie already hinted, right, the data will be in unstructured format. So to start with, Python will deal with the data in unstructured format, data in string. I mean, the entire text data that we are dealing with is string data. So when we talk about string, it is identifying the string data with quotes. It could be a single quote, it could be a double quote, it could be a triple single quotes, or it could be a triple double quotes, right? So like this, there should be consistency, and anything inside this quotes is string for us in Python. Now, we could have any character. It could be a number, it could be a letter, it could be alphanumeric, it could be a special character. Anything under this quotes is a string for Python. Now, if you want to process or pre-process rather the data, you need to understand how the text is actually written. And whenever we talk about text mining, by default, we will talk about English because that is your computer language. And this is what is used across the globe heavily, right, for computers. So we will try and understand how English as a language is written. To start with, this is called as space delimiter, isn't it? So every word that you see in English is separated by a space. So there is a pattern in which, or a standard, which is used to write, or which is followed to write English language. Now, using this, we split the data. I was explaining this. This is called as tokenization process. Ultimately, I need to break down my entire unstructured data into tokens. But when I try to do this, I will probably get a lot of junk data, right? So what I'll do, I will use the steps. For example, I will have to clean the data, right? So when I say cleaning the data, I mean, I'm following CRISP MLQ methodology. So I would have to first try and understand if I have typos, spelling correction, spelling mistakes in my data, I'll have to correct that. Then I will have to ensure that the case consistency is there. I also need to understand if there are any junk characters, special characters, punctuation marks, special symbols, all those things. Then anything which is not required from the text perspective, in general, we call this as stop words. And libraries like NLTK, NLP, your text blob, word cloud, all these libraries in Python will have predefined set of words as stop words. We will use that, or we can also use customized stop words to clean the unwanted text. Further, I can also ensure that the text is considered, the tokens are considered in single form of word. When I say single form, I'm talking about present tense, past tense. Different forms of the same word will be there. Ultimately, it is the same word. Like mine, mining, right? So these different forms can be manipulated to get single word. That is called as stemming process, right? So talking, talk. ing is basically the extension. So we will take the stem word, cut this all words so that we get significant importance to that main stem word. These are all the various processes that we follow for cleaning the text data, and we can use a library called RE to do this cleaning. Majority of the features are readily available in RE package, regular expression package. That's how I initialize my process, Bharani. And based on my requirement, I would probably deal with advanced concepts like word sense disambiguation, text normalization as well.
Wonderful. Yeah. Thank you. Thank you so much, Sharad. And here, a lot of, okay, let me ask you another interview question on what is the difference between stemming and lemmatization, and what should we prefer?
Thank you for the question, Bharani. Stemming basically is a process, as I explained, to ensure that we get the stem word. Now, this is basically to ensure that the importance to a specific action or a task is captured. A specific keyword, I would say. So, for example, we use the standard example, jump. I could have jumped or jumping. So you can see present tense, past tense, these kind of different forms of the same word are there available in English grammar. These are defined. But ultimately, it is the action that we are speaking about. So we need to capture the stem word by eliminating these leaf words, predecessors. This process of separating is called as stemming, where we consider stem word jump as a repeated thrice. So we are capturing the count. But there are certain words which probably will not give us the same word, in fact. For example, amaze, or I will say amazing. So if I try to split this word, right, ing, if I split, then I would get a word called amaz. Now, in a dictionary, you don't have a word called amaze, because I'm just removing the predecessor. Sorry, the successor, my bad. The end part. So the word that I'm getting is amaze, which is in dictionary, does not have any definition. Stemming does not look into this particular definition after the split, whether it is coming from a dictionary word or not, right? So that is a drawback that stemming has, which can be overcome by an advanced technique of stemming, which is called as lemmatization. Lemmatization is a way which is basically given for the developers to customize their approach. So we can have a dictionary defined. We can use a WordNet dictionary, which is by default available in the libraries, or NLTK library, or we can use a custom dictionary. And we can do stemming, splitting of the words based on that dictionary. If I have a specific word in my dictionary, only then I will split. Another very good example you can see is city. And if I take plural, cities. Now, if I split this, I get sit. There's no meaning for it. But if I try to have lemmatization performed on this particular kind of word, and if the city word is defined in my dictionary, then I will be able to split the word, capture the original form of the word, rather than, singular form of the word rather than plural form. This way, I will be able to manage some kind of customization. Depending on our requirements, we can try and achieve this. Which is better is purely, again, depending on your specific requirements. Bharani.
Yep. Thank you. Thank you so much, Sharad.